Hi, I am Ormillada from grade 9 Cuevas, and today I will be giving you a tutorial on how to solve quadratic equations using factoring and using quadratic formula. The reason why I am doing this is so that if any other students are confused with these two topics, then I will be the one to give a tutorial for them. So, without further ado, let's get right into the exam. That there is going to be 5 examples in this video, 1 example per case. This is the first part of the video, so let's get right into it. The first case will be factoring out the greatest common factor, or the GCF. And for this, we will use x squared minus 7x equals to 0. The first thing that we're going to do is factor out x out of this equation, since x is present in both x squared and 7x. So now, the equation will become x multiplied by x minus 7 equals to 0. Since this equation is in its simplest form, we can now use the zero product property. And this property states that if a times b equals to 0, then a equals to 0 or b equals to 0. This means that the factor must be 0. So, it's either that x equals to 0 or x minus 7 equals to 0. Now, let's solve these two equations. Since x equals to 0, then there is no other solution to it. That's our final answer for the first x. The second x, we need to isolate the x so that we can have the answer. Since negative 7 is in that equation, what we are going to do is to add the additive inverse on both sides so that that number 7 will get cancelled. Now we add the additive inverses. Now x is isolated and x is equal to 7. For the second case, it's called factoring the difference of two squares, or dots. Now for this example, I will use x squared minus 25 equals to 0. Now as you can see, x squared and 25 are both perfect squares. So when you factor them out, you will have x minus 5 multiplied by x plus 5. Now, since it's all factored out, we are now going to use zero product property. And that means that the two numbers or factors needs to be 0. So, x minus 5 equals to 0, then x plus 5 equals to 0. Now we are going to isolate the x. So what we're going to do is to add the additive inverses of these numbers. The additive inverse of negative 5 is 5, and the additive inverse of 5 is negative 5. So then, the numbers will get cancelled. Then we have the final answer, which is 5 and negative 5. Next case is called factoring perfect square trinomial, or PST. And for the example, I will use x squared minus 10x plus 25 equals to 0. The first thing we will do is to multiply the coefficient of x squared and 25. Since the coefficient of x squared is 1, we will do 1 times 25. Since it's 25, we are going to find two numbers that when multiplied equal to 25 and when added up equal to negative 10. And these two numbers are negative 5. Now, we will replace negative 10x in exchange for the two negative 5's. So, our equation will now be x squared minus 5x minus 5x plus 25 equals to 0. The next thing we will do is we group them up. So, we group x squared and negative 5x together, and 5x and 25 together. Next is we find the similar terms between the groups. The first group's similar term is x, since it's present in x squared and 5x. The second term's similar term is 5 because it's present in 5x and 25 can be divisible by 5. So now the equation will now be x times x minus 5 minus 5 times x minus 5. We add the similar terms and we come up with x minus 5 squared, or x minus 5 times x minus 5. Now we proceed on to the zero product property. X minus 5 equals to 0 and x minus 5 equals to 0. The next thing we will do is to add the additive inverses, and that is positive 5. So when you add positive 5 on both sides, the negative 5 will get cancelled and the x is isolated. So what we have now is x equals to 5. The next case is general quadratic trinomial with 1 as leading coefficient. So the example I will use is x squared minus 9x plus 14 equals to 0. The first thing I will do is that I will multiply the leading coefficient with 14. So that's 1 times 14 equals to 14. Then I will find two numbers which when multiplied equal to 14 and when added up equal to negative 9. Those two numbers are negative 2 and negative 7. Then I will replace negative 9x with those two numbers, negative 2x and negative 7x. So the equation will now look like this. Next, we group them up and find their similar terms. X is present in both x squared and 2x. And 7 is present in both 7x and 14 is divisible by 7. So now we will rearrange them so it will become x minus 7 times x minus 2. Again, we will use the zero product property. So x minus 7 equals to 0 and x minus 2 equals to 0. Then we add their additive inverses. For negative 7, it will become 7, and for negative 2, it's 2. So when we add them on both sides, x will be equal to 7 and x will be equal to 2. Last case is general quadratic trinomial with 1 as not the leading coefficient. The example I will use is 2x squared minus 5x minus 3 equals to 0. As you notice, 2 is now our leading coefficient. So what I will do is I will multiply 2, the leading coefficient, with negative 3. And that equals to negative 6. Now what I will do next is to find two numbers in which when multiplied equal to negative 6 and when added equal to negative 5. And those two numbers are x and negative 6x, because negative 6 times 1 is equal to negative 6 and negative 6 plus 1 is equal to negative 5. Now we replace the negative 5x with those two numbers and our equation will look like this. Next we group them and then find their similar terms. X is present in 2x squared and x. So x times 2x plus 1. And 3 is present in 6x minus 3 because when you multiply 3 and 2x, it's 6x. 3 times 3 equals to 1. The next thing we will do is to rearrange them so that it will now become x minus 3 and 2x plus 1 equals 0. And don't forget, we will now use the zero product property. X minus 3 equals to 0 and 2x plus 1 equals to 0. The next thing we will do, add their additive inverses. So, for x minus 3, the additive inverse of negative 3 is 3. So now, x is equal to 3. But 2x plus 1 equals 0 is different. So first, we will add their additive inverses. So it will become 2x equals to negative 1. Now, what we will do next is to isolate the x. So what we will do is to divide 2 on both sides so that the 2 on 2x will be cancelled. And what's left is x is equal to negative 1 half. And that is our final answer. So that's the first part of the video. The second part of this video will be teaching you how to solve quadratic equations using quadratic formula. So hey everybody, this is the second part of the video, and this part of the video I'm going to be discussing solving quadratic equations using the quadratic formula. So for those of you who don't know what the formula is, it is x equals to negative b plus minus sign the square root of b squared minus 4ac over 2a. So that's going to be our formula that we're going to be using to solve the equations today, and you may copy, and I'm just going to give you a heads up. This is called the discriminant, and there are different cases of discriminants, and that's going to be what I am going to teach today. So on to the first case. So our first case is going to be this one. So as you may notice, it's x squared minus 14x plus 8. So the first thing we're gonna do is to find what is the a, what is the b, and what is the c. So in this case, 1 is going to be our a because the coefficient of x squared is 1. Negative 14 will be our b, and 8 will be our c. So using the formula earlier, we're just gonna replace the letters into the numbers. So negative 14 is our b, so negative 14, then the plus minus sign, the square root of negative 14, the square root of negative 14 minus 4, our a is 1, and our c is 8. So that is 8 over 2, then our a is 1. So that is the formula that we're going to be using on this equation. So next is we're gonna simplify all of this equation. So negative times negative 14, since negative times negative equals to positive, so 14, then plus minus sign, the square root of, so what is the square root of negative 14? It is 196, since again negative times negative equals to positive. Now negative 14, no wait, negative 4 times 8 is equal to 32, times 1, 32, negative 32. So negative 32 over 2 times 1 is 2. So that's going to be our next solution. The next, we are going to find the difference between 196 and 32. So the difference between them will be 164 over 2. Then the next thing we're going to do is we're going to factor out 164. So when you factor 164, we are going to get 4 multiplied by 41 over 2. Next, we are going to find out the square root of 4. So since the square root of 4 is 2, we're gonna put 2 outside. So plus minus 2 square root of 41 over 2. We're almost done. So the next thing we're gonna do is, so this is our current equation right now. We are going to cancel out, or we're going to simplify by canceling out. So 2 cancelled, 2 cancelled, negative 2 divided by 2 will be cancelled, so will be cancelled. So then 2 divided by negative by 14 is equal to 7. So what we have left now is 7 plus minus sign square root of 41, and that's gonna be our final answer. Or you can do x is equal to 7 plus square root of 41, and x is equal to 7 minus 41 square root of 41. So that's our first example done. So move on to the next example or case. So this is the second example or the second case, and the second case is if the discriminant is 0, then the quadratic equation has two equal real roots. So the example that I'll be using here is this: x squared minus 8x plus 16 equals 0. So again, we're gonna find out our a, b, and our c. Our a is going to be 1, and our b is going to be negative 8, and our c is going to be 16. So then we're gonna just gonna replace our values. So negative b, our b is negative 8, plus minus sign the square root of negative 8 squared minus 4. Our a is 1 and our c is 16 over 2a, which is our 1. Now next thing we're gonna do is again simplify. So negative times negative is going to be positive 8 plus negative sign the square root of negative 8 will be 64, since negative times negative is equal to positive again. 64 minus 16 times negative 4 is going to be equal to negative 64. So therefore negative 64, since negative 64 times 1 is equal to 64 anyway. So anyways, then 2 times negative 1, 2 times 1 actually is equal to 2. Then we're gonna find out the difference of the discriminant. So 8 plus minus, so since 64 minus 64 is equal to 0, there. So the discriminant this time is 0, so that means we will have two equal real roots over 2. Now what we're gonna do next is, since 8 plus minus 0 is equal to 2, there. So if we separate it, it's going to be 8 plus 0 is equal to 2. Okay, then we're just gonna add these. Then our first x is equal to 8 over 2. Then simplify 4. It's our first x. Then our second x is 8 minus 0 is over 2. Then subtract these two, we will get 8 over 2 still. Then simplify 4. So as you may notice, we have two equal real roots, both being 4. So that's our second case, and we're going to move on to the third case. So welcome to our last example, or our last case, and the last case states that if the discriminant is negative, the quadratic equation has two distinct non-real roots. So what I'm going to use as an example for the last case is this: x squared minus 6x plus 10 equals to 0. So again, we're gonna find out our a, our b, and our c. So our a will be 1 since the coefficient of x is 1. Our b is equal to negative 6, and our c is 10. So then what we're gonna do next is just to rewrite our terms. So b is our negative 6, positive negative sign, the square root of negative 6 squared, since negative 6 is our b, minus 4, our a is 1, and our c is 10 over 2, and our a is 1. Next, we're going to simplify. So negative times negative equals to positive 6, plus minus sign, the square root of negative 6 squared minus 4, our a is 1, and our c is 10 over 2, and our a is 1. Then we're gonna find out our discriminant. Plus minus sign, the square root of negative 6 is going to be positive 36. Then negative 4 times 10, 40 times 1, negative 40. 2 times 1, 2. Now we're gonna find out the difference of our discriminant. So 36 minus 40 will be negative 4 over 2. Now, since our discriminant is negative 2, we know that our equation has two distinct non-real roots. So what we're gonna do with this negative 4 is that we factor it out. So we get 6, positive negative sign. So I'm gonna do negative 1 times 4, so that we get a positive number, so over 2. Then what I'm gonna do is I will take this one and I will make it an imaginary number. So what we get now is 6 square root of 4, then I for imaginary number over 2. Then what we're gonna do next is we're gonna simplify. 6 divided by 2, 3. Then 2 divided by 4, 2. Then the 2 will get cancelled. So what we have left is 3 plus minus square root of 4i. Or, so this x equals to 3 plus minus sign square root of 4i, or x is equal to 3 plus square root of 4i, and x is equal to 3 minus square root of 4i. So that is our last example. I hope you understood it despite my bad handwriting on this iPad. So yeah, that is all for this video. Stay tuned for more. Thank you.